Hi, I'm Pat. All right, we've got another equation they want us to solve. The directions even say to use an identity. But with any of these equations, it's always going to be a matter of being able to manipulate things algebraically and then applying some trigonometric knowledge as well. So that's where an identity is going to kick in, but also some other trig that you have to know. But let's see when we get there. Now what I would do for this one is, this is the equation that's given to us. Sorry, I should have pointed out a little bit of a spoiler alert. I already wrote down an identity up here that I think we're going to use, but let's just start with the equation that's given to us. Let's think about how we would approach it. And for this one, I think the way I would start is by doing a little bit of algebra, by noticing, for one, that there's a 2 as a factor, like a coefficient in front here, also there. And of course that -1, that subtraction of 1, that's easy to throw on the other side. So with some algebra, I think I'm going to do as a first step 2 parentheses and then cosine of 4t times cosine of 2t plus sine of 4t sine of 2t, close the parentheses. That was me factoring a 2 out of those two terms. And while I'm at it, I'm also taking that subtraction of 1 and throwing it to the right-hand side so that it equals 1. And I'm doing that because now I can even divide by 2. And so what's left, or what was left in the parentheses, is now this entire expression. Divide by 2 and get a half over there. But this entire expression, I really want to make sure we're paying attention to here. So that's what was left in the parentheses. And now I'm looking at that as the left-hand side of my equation. But here's the deal. If you get to a point like this in your work where you're really not seeing any other little algebra manipulations that you can make, this might be a time to start thinking about the trig identities that you've learned. So I told you this was a spoiler alert, but if you look through your identities, I think this guy is going to serve us pretty well. And I think that because, look at the right-hand side of this formula, and it's cos cos plus sine sine, which is exactly this expression of mine, right? Cos cos, sine sine with addition in between, addition in between. So I now know that I can rewrite this big, long expression of ours as the left-hand side of this identity, or formula, where it's a single cosine, and I just have to do u minus v on the inside of my argument, okay? So using that identity, I'm going to replace this entire left-hand side with just cosine of, and again, u minus v on the inside as the argument, and my u here is 4t, and my v is 2t. Something else you might want to be careful of is when you go to decide what trig identity to use, make sure it's fitting appropriately. And what I mean by that in this case is that if we're going to use the right-hand side of this identity or formula, it's cosine u times cosine v plus sine of the same u times sine of the same v. So it's important to realize that I've got a 4t here and a 4t there, and a 2t here and the same 2t there, okay? So this is my u, 4t, and this is my v, the 2t. And I'm subtracting because I'm looking at the left-hand side of that, okay? All right, still equals 1/2. And you hopefully at least feel better at this point in your work because that's a much smaller, more manageable equation. Okay, and in fact, I can do even better because 4t minus 2t, I've known how to do that kind of combining of like terms for ages. This is cosine of just 2t equals 1/2. Okay, good work. But we're not done. We're not done until we get an answer for t, right? T equals. So cosine of 2t equals 1/2. Now you want to start thinking trigonometrically again. Let's think about some trig. If I have the cosine of something equals 1/2, now you're starting to think of what are those angles where the cosine is 1/2. So, for instance, cosine of an angle equals 1/2. I know that that occurs at pi over 3. I've got some blanks to fill in here, but I'm trying to share my thought process with you is just from this equation. Cosine of an angle, no matter what's inside there, I don't care exactly, not yet, cosine of something equals a half, I know that that something equals pi over 3. That's where cosine has a value of a half. All right, so now let's fill in the something. It was 2t. So see, if I tell you I don't care what's inside here, no matter what algebraic expression is on the inside of your cosine, just put that on the left side of this equal sign, because you're saying that that's the angle that equals pi over 3. And we're still not done yet, but you can see at this point, it's not too involved algebraically to get t alone. We'll just divide by 2, right? But there's still some more trig to be thinking of. For instance, this pi over 3, I hope made sense to you that that's where cosine has a value of a half. But because trig functions are cyclic and they keep repeating themselves, that could happen anywhere if I start adding or subtracting 2 pi. I'm pausing because I actually want to put 2 pi, and I could spin the wheel as many times as I want, so it's actually 2n pi. Start by thinking 2 pi because that's one full rotation, but realize you're allowed to spin the wheel as many times as you want, and that's where the n kicks in. Okay? All right, so this is really good. And now maybe I'll even finish off the algebra here. I told you all we have to do is divide by 2, right? T equals pi over 6 if I divide by 2, plus or minus n pi if I divide that second term by 2. Okay, it's really good work. But wait, there's more. When we considered, at this point, what angle has a cosine of a half, we figured it was pi over 3, remember? But there's another angle that has a cosine of a half. So that other angle is 5 pi over 3. All right, that'd be down in that fourth quadrant. There's another location on the unit circle where cosine has a value of a half. So you have to include that in your work as well. And then from there, my work does look the same as what I've already done. The angle expression is 2t plus or minus 2n pi, and then get t alone by dividing by 2. And we're looking at this. So infinitely many answers here, but infinitely many more answers over here as well. Okay, a lot going on here, but good thing is when you get to the answers in these problems, you should be proud of yourself. Okay, all right, I'll be proud of you too if you try some on your own.